Assalamualaikum friends. In the coming video we are going to talk about the retaining walls. Retaining wall is a part of the structure design course. If you are studying civil engineering, then this video will be very helpful for you. Let's start our topic. First of all, what are the retaining walls? Retaining walls are actually those rigid walls which are used to retain the soil, water and other fluids or other loose granular materials having a vertical abutting edge. These materials like soil or water act a horizontal lateral pressure on these walls, and these walls are constructed to resist this lateral pressure. For example, basement retaining walls of buildings must retain the soil surrounding the structure. Similarly, in the highway or railway bridges, embankments must be retained vertically. Next, we have the types of the retaining wall. First type is freestanding retaining wall. Second is gravity retaining wall. Third is cantilever retaining walls. Fourth and fifth are nearly similar, having the same design, but having a one main difference that we will discuss in the coming video. So, first type is freestanding retaining wall. These retaining walls have no extra load or restraints of superstructure at their top, means they are free from load, and these retaining walls are mainly used for decorative purposes. We have second type, gravity retaining walls. Gravity retaining walls are those walls which use their own weight to resist the lateral earth pressure, and these walls are constructed with brick masonry, stone masonry or concrete, and steel reinforcement is not provided in the gravity retaining walls due to the economical issues. When the height of 3 to 6 meter is needed, then we will provide these gravity walls. Third type is cantilever retaining walls. Cantilever retaining walls are constructed of reinforced concrete. They consist of relatively thin stem than gravity retaining walls and a base slab. Base slab is further divided into two parts, toe and heel. These walls are also used for the height from 3 to 6 meter. We will discuss the components of retaining wall in the coming video. Here is the steel reinforcement of the cantilever retaining walls. In the stem, we will provide main reinforcement near the backfill side of the retaining wall, while in the heel we will provide reinforcement on the top, and in the top we will provide reinforcement at the bottom due to their bending moments. Fourth type is counterfort retaining walls. When we need the height more than 6 meter for a retaining wall, we will provide counterforts. These counterforts are bracings which support the main stem of these retaining walls. These counterforts are additional support for the stem of these retaining walls. Here we will see the difference between counterfort and buttresses retaining walls. In the counterfort retaining walls, the counterforts or bracings are provided on the backfill side, while in the buttresses retaining wall, these counterforts are provided on the toe side. Next, we will see the components of a cantilever retaining wall. So, our first component is stem or R. Stem is actually cantilever wall vertically projecting out of a horizontal base at the bottom, where it is rigidly connected to the base slab. So, thickness of stem is kept nearly h by 14 to h by 8, where h is the total height from top of the stem to the bottom of the base slab, and minimum thickness at the top of the stem is kept nearly 200 mm, and in case of gravity retaining wall, this thickness might be greater than 200 mm. Our second component is the base or base slab. This is the foundation slab of a retaining wall, which is further divided into two parts. These two parts are heel and toe. The thickness of the base is kept h by 14 to h by 10, where h is the total height from the top of the stem to the bottom of the base slab, and the width of the base slab is kept nearly 40 to 75% of overall height. As base is further divided into two parts, heel and toe, first we will see heel. Heel is that portion of base slab that tends to lift up due to lateral pressure acting due to soil and present toward the soil fill. Its primary function is to transfer backfill soil load to the base, and Its second function is to provide some resistance against the horizontal sliding. Next, we have toe. The portion of base slab that is pressed downward into the soil present away from the retaining wall is called toe. Toe is actually 1/3 of the total base slab width, and its primary function is to make the resultant of applied service load forces passes through the middle third of the base. Next, we have the key or lug. It is an optional component and it is provided in a retaining wall in case where resistance against the sliding is insufficient. We know that the soil puts a horizontal lateral pressure on the stem of the retaining wall. When this lateral pressure is very high, we provide the key. This key increases the sliding resistance of the wall by transferring the lateral force to the abutting soil. Next component is expansion joint. Expansion joints are provided to avoid the accumulation of thermal stresses like expansion or contraction. Spacing of these joints depend upon three factors. First one is temperature variation, coefficient of thermal expansion which is constant, and movement allowed at a particular joint. Next we have drainage pipes and weep holes. Whenever we face the wet situations around the retaining wall, we provide drainage pipes. These drainage pipes and weep holes allow water to escape from behind the wall. We know that the saturated soil exerts the maximum lateral pressure like a viscous fluid, which makes the design of a retaining wall quite heavy and uneconomical. So, to make this soil unsaturated, first option is provide weep holes and the second option is to provide the tile drains covered by the granular materials to avoid the plugging or choking of the openings. Now we have the forces that acts on a retaining wall. So first force that acts on a retaining wall is active earth pressure, which is due to the lateral horizontal pressure of the soil on the hillside. Second, we have passive earth pressure, which is due to the soil which is on the toe side. Active and passive earth pressure are opposite to each other. Third force is the surcharge load, which is denoted by the QS, and this surcharge load could be due to the traffic load or any other load on the top of the backfill. Next force is the self weight of the wall, denoted by WC, and fifth force is the weight of the fill or soil on hillside. This is actually the weight of the backfill. Sixth force is the upward soil reaction on the footing. It is due to the bearing capacity of the soil, and bearing capacity is the reaction force against the load acting downward. Thank you for watching this video.